Good morning. This is the ShellSort process. The ShellSort is a generalized version of the insertion sort algorithm. It first sorts the interval elements that are part from each other and successively reduce the interval between the elements and store. The interval between the element is reduced based on the sequence. Use sum of the potential or optimal sequence. The array can be sorted in 6, 1, 2, 7, 4, 8, and 5. This is the original sequence for n divided by 2, n by 4, etc. n. The first interval you can try int n by 2, int 8 divided by 2 equal to 4. So we need to take the first interval 6 to 2 in between the numbers of 4 elements. So suppose we need to sort the these array. Initial step, we are using the shell original sequence n divided by 2, n by 4, etc. n as an interval in our algorithm. In the first loop, if the array size is n equal to 8, for n equal to 8, then the element lying on the intervals of n divided by 4 are compared and swapped if they are not in order. The 0th element is compared with the 4th element. If the 0th element is greater than the 4th one, then the 4th element is first sorted in temporary variable, and the 0th element is greater than it is the stored in 4th position of an element, stored in temporary positions. Arrange the elements at n divided by 2 intervals. This process goes on for all the remaining elements. Rearrange the elements at n divided by 2 intervals. In the second loop, an interval of n divided by 4 equal to 8 by 4 equal to 2. This is taken, and again the elements lying at the these intervals are sorted. Put 6 before 7, 2 elements will be solved. The second intervals you can try int n divided by 4 equal to 8 divided by 4 equal to 4. You might get confused at this point. All the elements in the array lying at the current intervals are compared to the another elements. The elements at fourth and second positions are compared. The elements and second and 0th positions are also compared. Then assign the temporary variable of 6. So the 8th and second position will be skipped. All the elements in the array lying in the current interval compare with the 6, 7, and 6. These are all compared together in the temporary variables. Put 5 before 6. The same process goes on remaining elements. Rearrange the all elements at n divided by 4 intervals. Finally, then the interval is n divided by 8 equal to 8 divided by 8 equal to 1. So then the array element lying at the interval are one sorted array. The array is now completely sorted. The ShellSort is an unstable sorting algorithm because this algorithm goes not examine the elements lying between in the intervals. In the worst case complexity less than or equal to order of n square, the worst case complexity of the ShellSort algorithm, sorting in the interval of 2 elements. According to the position of a theorem, worst case complexity of a ShellSort, order of n log n the whole square. Remaining put 1 before 2. In the third interval, try in integer value n divided by 8 equal to already we saw in the array interval of the algorithm. The array interval of an algorithm can be concluded in the uh, part of sequence of a common sequence include the sequence of an uh, keyboard sequence. Compare the elements separated by the gap and swap them if they are in the wrong order. The step can be performed using a variation in insertion sort. Put before 4 before 5. Put before 2 before 4. Put 1 before 2 or 7. In the order repeated the next smaller gap in the sequence. When the gap is 1, perform a final insertion sort. ShellSort is clearly superior to any of these short list of even 100 records optimized quick short is clearly the best overall algorithm for all but list of 10 records. Even for small arrays, optimized quick short performs well because it does not one partition step before calling insertion short. ShellSort does not maintain the relative order or equal element, making it unstable. Performance depends on gap sequence. A gap sequence is division by order of n, the worst case complexity. So we can assign the temporary variable of for the sorted array element from the temporary array element. Now the shell sort is complete with the array interval of n divided by 2, 4 divided by 2, etc. until 1 divided by 1. This is the array short, completing the array short algorithm. When there are a large number of elements using a larger intervals, at the beginning usually reduce the number of instructions when an interval of 1 is used. Usually faster than pure insertion. Uh, Insertion is the one of the advantages of ShellSort. The ShellSort completely order to ascending order to descending order with the given array intervals. Thank you.